So step one, first thing we need to do is add all the forces onto the diagram. So the weight of mass of 2m is 2m times gravity. Weight of that one is 3 mg. What's the force holding each of those particles up? It's the tension from the string. So we've got that on both sides. And what's the force that the pulley's feeling? Well, it's the tension down from the string the other way. And what's actually happening? Well, the pulley on the right, so the particle on the right will be moving down, it'll be going that way, therefore the particle on the left will be going up that way, be accelerating because we have an imbalanced force, and the acceleration by which that one's moving up will be the same as the acceleration by which that one's moving down. Label the particles P and Q. So let's look at the forces. So at P, which way we're going to resolve? Vertically is positive because that's where it's accelerating. F equals ma. What force have we got? We've got the tension up minus the weight down is equal to the mass, which is 2m, times acceleration a. At Q, and note this bit is important. At Q, we resolve with downwards as positive because it's accelerating down. Okay, so then it's going to be that weight down there minus the tension, which is what's slowing the movement in this case, is equal to mass times acceleration. Okay, so F is ma. 3 mg, which is the weight, minus the tension, which is what's slowing this acceleration, is equal to the mass 3m times acceleration a. We then have two equations. Okay, remember g is a constant. We've got two equations with t that's unknown and a that's unknown. So we can actually solve these simultaneously, and it's always going to look like this sort of thing when it's pulleys. Add them together, 3 mg minus 2 mg, the t's will cancel out. So mg is 5 ma, your m's cancel out. So the acceleration is g over 5 meters per second squared. Then we want to find the tension. Well, now we can look at either one of these equations. We know the acceleration. Add that over, so t is 2 mg plus 2 ma. And then solve that. However, it's going to be in terms of m because the mass of those objects will affect the tension. Okay, I've done it like this because I didn't have a calculator on me. So we'd have 6 over 5g from this bracket here. So then we get 12 over 5 mg is the tension. Part D, what's the force on the pulley? Well, if we just remind ourselves what the situation at the top looks like. So this is our pulley here. It's being held up by something. Okay, it's attached to this surface or whatever. Then we've got the rope down there and the rope down there. And remember, each of these ropes feels a tension down. So what does this pulley actually feel? Well, this rope is dragging it down there and dragging it down there. So it's tension and tension. So if we look at F equals ma for the pulley, let's take upwards as positive. What's happening? Well, it's staying still. It's not accelerating. So acceleration is 0. So this force upwards must be equal to 2 lots of t going downwards. We know that t is equal to 12 mg. So sub that in and we get 24 mg over 5. Now, and pretty common in these questions, we look at a bit of suvat. So we want to know the distance travelled, so S is the thing we want to know, in the first 4 seconds. We're not interested in the final velocity. We know it starts at rest. So the question is, how do we link S, U, A and T? S is ut plus a half at squared. U is 0. Half times acceleration is g over 10 times t squared. Simplify that, 1.6g, 15.68, which is going to be 16 meters to two significant figures. And then we'll look at the assumptions. Part F actually only asks you for one of these assumptions, but they are both really, really significant. It's a smooth pulley, and it's an inextensible string. So as soon as we see smooth, we think that means no friction. What does that actually mean in this case? It means that the pulley doesn't take any force, so the tension on either side of that pulley is the same. So the tension is constant throughout the system, which is why we can use the same T on both sides in both of our equations. Inextensible string, it's not elasticated, okay, it's all moving together, therefore the acceleration is constant throughout the system.